Hi everyone. So I'm here to retry the Frost demo. Thank you, Paco and Aditya, for giving me some space to try to do that. Wi-Fi went down right when I was going to do it, but let's go ahead. So my idea is to send a post to ZECpages, right, which is a memo, like a posting board where you can send message through Zcash transactions. So I have Y wallet here, which has been preloaded with just a viewing key, so it's not supposed to be able to send transactions. So I'm sending 001 ZEC, which is what required by ZECpages. And let's go. This is a Frost signed transaction. Okay, let's click send. So what's happening now is that Y wallet is create a transaction plan, right? So it's showing me, oh, you're spending this much ZEC from the orchard pool and sending, since ZECpages use the sapling, so you're sending to a sapling address. So this is what, if you're using Frost, each person will see this transaction plan. So let's click send. This will not actually send it, but will generate a file containing this transaction plan, a JSON file. So I just saved it. And let's go ahead to our terminal. So this demo, it's a command line, but of course, in a real application, users will do this on a wallet, on a graphical interface. So I'm running this program that I wrote based on Y wallet code, which will sign a transaction. So I'm sending here the JSON file, and the output will be this raw file. It requires the full viewing key that I generated previously. So this full viewing key for Zcash is actually from a Frost wallet, right? So it's doing this thing, it generates the transaction and the hash, right? And when you send a Zcash transaction, what you really sign is the hash of the transaction. So this is the thing that we need to sign with Frost. And this randomizer, like I mentioned in my talk, is just something that is required by Zcash protocol. So let's go ahead and run the coordinator here in this tab. So I need the public key package. I generated this previously. It's right here. Pasted it. So how many participants will do this signing? So 2. I generated 2 out of 3 wallet. So I have 3 shares, but I just want to sign with 2. The first participant that will do this is participant number 1. So I need their identifier. And the second participant identifier, which is 2, is just the way it's encoded in a bunch of fixed byte array, but it's just the number 2. So I need to specify the message that I want to sign. Like I said, it's the hash of the transaction. And now I need to actually run Frost. So each participant will run this in their own wallets or computers. So here we have participant number 1. I need their key package, which is I pre-generated. It's right here. And I need a participant 2 key package, which is right here. So what just happened, each participant generated their commitments, and they will send this commitment back to the coordinator, right? So here's the, of course I did something wrong. Just retry this, the public key package is right here. The number of participants, 2. Identifier, I can pick this up here. Identifier 2 right here. The message, I think I forgot to press enter. Yeah. These encoded commitments for participant 1 right here. For participant 2, right here. So each participant generated commitments and sent back to the coordinator. Now the coordinator needs the randomizer, which I generated in my program. So now what happens? The coordinator built the signing package, which contains the message and the commitments, and sends it to each participant. So participant 1 got the signing package, participant 2 got the signing package. The coordinator, in the specific case of Zcash, he also needs the randomizer, so he also sends the randomizer. And there you go. Each participant generates a share of the signature, right? Which is this thing here. So each participant sends the share back to the coordinator. So 1 sent its signature share, 2 sent his signature share, and we finally have the final signature. So yeah, thank you. So what happened here is just signed a transaction using Frost, using a key which is not actually present anywhere. The coordinator doesn't have the full key. Participant 1 doesn't have the full key, neither participant 2, right? They just have shares of the secret. But now we have a signature for that key, which doesn't exist. So let's get the signature and go back to this program here, which will actually write out the signed Zcash transaction. So we can go back to my wallet. Remember, this is a viewing-only wallet. I can show you even the keys here. There's nothing secret here, just the viewing key. And I can broadcast. So I go to Advanced, Broadcast, select the raw transaction that I just generated, and it worked. It just printed the transaction ID here below, and this means that we have just sent a frost-signed Zcash transaction to ZECpages. It takes a bit to appear there, so I won't wait, but that's it. That's the first ZECpages post. I did test with a like, but it's the actually first frost-signed ZECpages post. Thank you.